by saying that I'm really happy that I'm able to do this live stream today. Those who are my subscribers, they'll be getting the notification for this, and I hope I can see all of you there. So, in today's live stream, the title is Corrosion, What Art Thou? What is corrosion? Something that has really made people want to do so much research and so much work all the time, and that's what makes corrosion really unique. So, the point of doing is to see how two different categories, two very important pillars of this field work. So, in this case, you have researchers on one end and you have industry. Both of them are doing excellent work. They always have interaction with each other, and there is a lot of give and take that goes on over here. However, I have worked as a researcher and I have seen how the people in research work as well, people in the industry work as well. So, I know that sometimes they do not really match, the way they think does not really match. So, that's what actually provoked me to give this webinar, and if you have watched my previews recently, there are 3 major topics that I have shown, and you will be able to check the topics previews over there. So, so let me just take a 2-minute break. I would like to just send the link again to everyone, and we'll get back. We'll start off with the PPT. Welcome back, and thank you for your patience. So let's begin. First of all, who am I? I am Dr. Shamadi Ranade. I am basically what you can call a corrosion person. So, I am always reading and writing and teaching corrosion. My background is metallurgical engineering, and I have done my master's and PhD in specifically corrosion. And second is why this webinar. So, as I said, this webinar is to bridge the gap between research and industry. A small presentation of how researchers think about the problems, corrosion problems, and how they present their data. A bit about how the industry expects the data to come to them, or what do they look for when they are trying to get better corrosion properties in a particular material, and finally how can they communicate effectively. If the researchers have worked really hard to get a really superior quality of coatings or inhibitor or material, how do they tell the industry and convince them that this is better than what you are currently using. So, that is the point behind Corrospective, and my logo over here is visible. As you can see my logo, you can see there is a C which stands for Corrospective. Then there is a small cathodic protection given over here, and then there is some kind of a coating that's given over here, and you have small chemicals that go on indicating the corrosion inhibitor. So, that's how the corrosion really works. So, now we start with a talk about what corrosion is. Most of you are already working, so we know that corrosion is environmental degradation of metals and alloys. Corrosion is kind of opposite of refining. So, when you refine, you are pulling that material, you are putting in energy to pull that material from the from an unrefined state or a lowest energy state to a refined state, that is at the top. Now, when that material encounters elements like oxygen, water, they will react and again form corrosion products or say or compounds which will again have a least energy state. So, that will be the block coming back down, and thus this coming back down is your corrosion. So, what we are really trying to do is we are trying to pull or keep that block to the top to the best of our ability, and that is done by a number of corrosion prevention methods that have been used at the moment. So, any corrosion that happens is because of a corrosion cell, and when you have a corrosion cell, you always have 5 main components. The first is anode, which is the thing that always corrodes. Second is cathode, which supports anode, supports the reduction reactions, and it is the cathode actually which may cause the corrosion to occur. So, it may cause the anode to dissolve. The third is electrolyte. Electrolyte is that medium which brings into contact the anode and cathode physically. Electrical contact is that connection between the anode and cathode which allows the movement of electrons, and potential difference is the gap between the abilities which promotes how severe or how fast the corrosion is going to be and which one is going to corrode. So, in a typical diagram which we see, if you have an anode, then the medium is going to dissolve the anode and the cathodic reactions will support. So, the electrons that are left will go through the connection to the cathode. Now, in general we do not always have 2-3 different cathodes and anodes. All of the components are present on a single material. So, when you have a single material, you can actually see you have a particular part which will dissolve, the surrounding areas will support the cathodic reactions, and you will have the water, you have the flow of electrons. So, the electrolyte which actually promotes this is going to be deposited over here. So, whenever we are trying to stop corrosion or we think about corrosion prevention methods, we are basically trying to eliminate one of these. So, either we try to prevent electrical connections or we try to prevent the connection of electrolyte onto this surface. Now, the first instance that I would talk about is corrosion of aluminium alloys. It is really important, and primarily because it is used in a very important part, that is the aircraft industry. So, aircraft or defense uses a lot of aluminium alloys, even the automotive companies use a lot of aluminium alloys, and their mechanical properties are important in determining which of them will be used. So, if you see here the machining properties, so you will have good machining, you have a high strength, and then you will have good formability, you will have toughness. All these properties will actually promote the use of aluminium alloys for this application. Now, as you can see, the focus is majorly on their mechanical properties. So, selection of these alloys will depend on the data sheets which will contain the composition and the mechanical properties associated with that composition, as well as with the heat treatment that is given to each of them. So, if you see over here, we can see that the mechanical properties or the way in which the data showing that 7085 is good is presented over here. So, the focus is more on showing how it is better that we use 7085. Now, if you look, okay, at this point we have everything, we will start using 7085 for our work. Over the age, over the operation, you will have corrosion problems, because that is a natural way in which a particular problem will occur. So, you have corrosion resistance over here, and that is why they will give corrosion resistance as it is given here, but you can see there are just 2 lines. So, you have exfoliation corrosion and the rating is EB. So, for an experienced person, yes, EB may make sense, but otherwise it does not really make sense. EB means your this particular aluminum alloy will definitely undergo exfoliation corrosion, but it will not be that severe. So, to come to this point of rating, researchers have done a lot of work behind it, and after which this standard was created to give a particular rating. So, when we actually want to see, so what is this? What does actually happen? Exfoliation. Technically, it is kind of intergranular corrosion. So, you have longitudinal grains of aluminum, and on those longitudinal grains you will have on the grain boundaries there will be intergranular corrosion, which will lead to lifting off of the grains. So, basically these are grains are these entire layers are going to be lifted off the surface. So, if you have a wing, you can imagine lifting off of the layers is disintegrating of the wing structure. So, that is very dangerous. Now, to actually go through what happened, so that is how the researcher, how industry would look at. Now, researchers who have worked so much on corrosion have actually gone to nano and micro scales. So, they would do all kinds of tests of current and potential transients, and then they would have results. So, they will try to show which actually material will lead to such at which point exfoliation will start. So, these graphs or the potential measurements have been done over the time of the test. So, the exfoliation test is majorly an immersion test. So, you immerse it in acids, and in this test they will measure the change in potential of that material over time. So, at this point, after a certain amount of time, they will see a break, or there may be certain changes that may indicate that okay, it is at this point that the exfoliation may start. Further, they will do some more micrographical measurements and say that the initiation can be due to a crack, or initiation can be due to pitting, and the cross section will show that the exfoliation will grow deeper. So, the depth of exfoliation is measured to show which one of the heat treatments may be more severe. So, now the conclusion in such research papers is usually to show that one particular heat treatment or one particular alloying element is better than the other alloying element, or say certain modifications have led to lesser exfoliation corrosion. Maybe they may apply mechanical stress and say that okay, mechanical stress may lead to higher corrosion resistance, higher exfoliation corrosion or lower exfoliation corrosion. So, that is good. Now, you can see that the way in which exfoliation is treated in the industry is so different than what is actually done in the research. So, it is really important to communicate these great results to the industry, and so that they make the best possible selection. Why is this necessary? Because we may have say 7085, we may have 7085 from some another company, and that other company or the 2-3 companies, they will have a similar exfoliation resistance. So, the EB is more of a qualitative measurement. It is more of a looking at the structure and comparing it with the pictures in the standards and trying to see how the measurement is done. So, that is the point behind doing the exfoliation test. So, when you want to choose between 2-3 data sheets, or you have similar mechanical properties, and then which has a better corrosion resistance. In that case, such a qualitative rating may not always be enough. So, here then the researchers have to communicate their results so that they can match the ratings for each temper, or if they have done a particular if they have a research paper, they can match their depths or their results with the ratings that are given. so that whenever whenever the industry is trying to form the standards or form the data sheets, they can have this, and they can also have a corresponding depth of penetration of that particular data, of that particular aluminum alloy. So, this will help in actually understanding that how different that rating can be. So, here both the tempers have the same rating, but if we actually go to that penetration of depth, say time of failure or time of inception or time of start of the failure, then those quantities may be different for the two tempers, and in that case that would be a better selection choice. So, when a presentation of data in the last research has a lot of different parameters like electrochemical, corrosion potential, corrosion current density, etc. Now, when they present this data, it is more focused on the quantities. So, when they say that its corrosion rate is such and such, it does not really make sense if it is given in the data sheet. On the other hand, industry wants a quick answer. So, whether it is good or bad, is the rating excellent or very good or poor. So, when the researchers want to communicate, they have to remember this requirement of the industry. Further, if the industry has to have a certain help from research to do testing or exploration of new materials, it is necessary for them to tell them exactly what they need from the researcher, so that they can focus on that topic and get the best possible solution in terms of the presentation of data. So, the industry should also consider what is given in their data sheets and if it requires something more. So, how to communicate, how to integrate, what can the researchers do? The best way that I have learned is to use pictures, use plots. The plots help to pinpoint exactly which is the best and which is the worst. So, there is no problem with the electrochemical parameters such as how much of amperes per centimeter square or milliamperes per centimeter square, and as a result it is always better to use plots and transform it so that we can actually go to them, we can actually use it, the industry can use it. So, even if you do electrochemical testing, if you are a researcher, you can convert it into MPY or MMPY, and then you can check out so that MPY basically is the mils per year, MMPY is millimeter per year. So, if you tell that even if aluminum will basically undergo pitting, so the pitting will give you a certain I-core, that is a corrosion current density, and that can be transformed into such quantities. So, if you tell the industry that this has a better corrosion current density, they will not really care about it, to be very frank, because that is not usable in the normal day-to-day life or when they are machining that particular component. However, if you really talk about it in MPY or MMPY, that is a better idea. That gives a better idea to the designers of how they can frame those components and the dimensions. What you can actually as a researcher do is transform this and do the exfoliation testing and relate your depth of attack and the electrochemical parameters to that EXCO rating that you have got, so that when all of the researchers decide to relate the ratings to the depth of attack or try to quantify the ratings, those quantities can be included in the standards and then can be used in the data sheets. So, it is best to find that golden point. Golden point means you have shown that your particular alloy is working well in exfoliation testing. You can then go on to say that this particular rating, this depth of attack, and that would be the best possible condition, and this would be then useful to directly go and be put into work in the industry. Now, if you are an industry person, I am from experience, I know that you will not really have the time to go into all this time, but it is my suggestion that it is and usually it's possible that it can be done a third party testing for the form samples, not just the sheets, but when you actually do make your samples, the entire samples should be tested for excoriating, because now if you have a big wing, obviously you can't do that, but if you have smaller samples, or you have a part of that particular samples after forming, the forming operation will change the grain structure to a small time amount. So the exfoliation test should be done with the other electrochemical parameters for your formed samples as well, and that will help you to see if the excoriating that has been given to you is actually matching the formed samples or not. So that it will if it is not matching, or you have to have something done, or you have to have some corrosion prevention method, you can actually do it after that. So in that case, when you ask for this third party testing, you have to ask them to, otherwise if they give you these, if they don't give you the plots, you will have only the numbers, and that will help you in the immediate. But if further going ahead you want to do a failure analysis, you will not have the data of that original sample. So basically this has to be a baseline, and that baseline will help you to do some change up in the process. So what would such an integrated data sheet look like? Integrated data sheet would mean that you have a certain in addition to the rating, you also have this values where you can estimate the depth of attack for each temper separately with respect to a certain stress. It will also mean that you also have a corrosion rate for pitting to start for different areas. Thus, it will help in integrating the two fields. The next example is for coatings. This example for coatings in this particular case is internal coatings. I selected this example because internal coatings means they have to really take care of the chemicals and water that may be present inside. So their point is to have all the properties which will prevent any problems. Now selection starts from, as an example, it starts from the technical data sheet. What is special about this coat of any coating that you might select? So when you want to have internal linings, they will usually have film thickness, or that is the thickness that you would want. Then you will have the color, and then there will be the resistance. So as you can see here, this is also a qualitative measurement. So you have very good water resistance, does not tell you have excellent solvent, excellent chemical resistance. This does not tell us exactly when that coating will start degrading, what exactly how the water is getting resisted, or what are the coating resistance properties in quantitative term. So that's why even when you have you have excellent water resistance, everything, there may be issues with coatings or maybe selection. So if you have two TDS and both have this exact quantities, then what's the difference? The difference comes in actually quantifying these properties. So quantification depends on the components. So example, composition is usually given in the material safety data sheet. So the material safety data sheet consists of the epoxy resin and xylene, etc., and may consist of two or more components. So you will have some more different compositions, and these MSDS of two coatings will tell you what the difference in them is. Still, the ratings do not really change, right? So still we still know that water resistance is very good, excellent, etc. So these are based on the appearance of the coatings when they are exposed to the electrolytes given in this standard or related standards. So what does this mean? The representation of data is again important. Another point is they have given here the cleaning parts. So the cleaning is also really necessary. Now presentation of data in research starts from material chemistry. So they'll start with the material chemistry, go on to measure their properties, and then see the physical and chemical changes in the coatings. Then the adhesion impact test and salt spray are done. But from this to the industry, only the physical tests are communicated. They will that's why in the technical data sheets you'll mostly see salt spray, the chemical water resistance, water absorption tests, etc. That's why all the quantitative measurements are eliminated, and the technical data sheets are left with qualitative ones. So this kind of works against what the material will be. So this is my work which we did in developing new coatings. Now as you can see, we started with the chemical composition, and then we saw the changes in the chemical composition with respect to the different modifications in the polyurethane coating, and we tried to understand why those changes happened. Then we went to see how the heat or high increasing temperature can affect the polymer changes in the coating. Further, we did the electrochemical testing. Now electrochemical testing here showed us very good corrosion, very good behavior. So the water resistance, chemical resistance that you see would be this quantity, which is called the body impedance, and that is a part of electrochemical impedance spectroscopy, a non-destructive technique. So this technique is useful to try and see how the so this technique is useful to see how the coating is in intact state. So we are not destroying it, we are not putting a scratch in it, and nothing. We are exposing it to the medium for a long time and then doing these tests. So we can quantify, and we can actually see at what point or after how many days the reduction in the impedance or coating resistance can happen. After that, of course, we go on to the qualitative measurements, and we can also see that as you can see here, after 6 months you do long term measurements and redo these impedance tests, so that we can see, we can relate these good, excellent, very good to the quantitative value, and that is better helpful in a better way. Further, the salt spray test also shows us that also gives us which one is the better coating. But as you can see, there is no way to quantify, because this also looks good and this also looks good. Just at the face of it, these look quite similar, so we really don't know which one is the best. That's why electrochemical impedance can help in quantifying. So now when I want to communicate my results to the industry, what should I do more than what I did here? I can do the EIS for these ones at the start. So what could I have done more? I actually do the EIS at the start of the test and end of the test, and try to quantify the exact change in the impedance in these two cases, so that although it looks the same, I can get the number of what the degradation is going to be, and that would be much better. So as a researcher, I need to quantify my results and communicate them, but I also need to do more tests on this with respect to the chemical standards that were given in the TDS. So coating the solvent, chemical resistance and solvent resistance, water resistance, etc., and that will help to that I can do the quantification and communicate it, so that they can match it with the excellent, very good standards that have been given. So, an integration of the data sheet would be, again, as a researcher, use plots, use more impedance and try to quantify the salt spray test. As an industry, you can do relate the EIS data, you can to the water absorption, you can try to use the non-destructive techniques to quantify all the tests that you do, so that you can see the exact time when your coating will fail. The point is not just to get the coating to pass the tests. As a baseline, you have to know when the coating is going to fail. So, long term tests are really required. So, an integrated data sheet would look something like this. We already have the original. In addition to that, the water resistance will have impedance and corrosion rate, or solvent and with have impedance and corrosion rate. Chemical resistance will also have the impedance. If you have a salt spray, that should also be the impedance. One more thing that the researchers have to talk about is the surface profile. So, check which surface profile is used for your application and use that surface profile in your experiments, so that these results would be more relatable to what is done in the industry. Now, the next topic that I would like to talk about is corrosion inhibitors. You typically work as a protective barrier. So, it is like kind of a temporary coating. So, now as you can see here, we are trying to eliminate the contact between the electrolyte and the anode. So, that is how the corrosion inhibitors would work, and they usually work as temporary barriers against that particular medium. So, they are categorized in different forms, and you may have interface inhibitors, you may have scavengers, vapor phase, etc. Usually, when we look at this, we think of oil and gas, marine, automotives, etc. But there is an important parameter where you have machining done for different materials, and during the machining, during the machining, the components may get rusted. So, that is a really important part, especially in case of gears or transport of marine equipment. You may have rust occurring while the machining is going on. So, that is really dangerous, and that is why they will have rust preventive oils. Now, rust preventive oils are a lot in number. So, it is not really easy to pinpoint that this is good and this is bad, and that is why it is best to go to their compositions and their TDS. So, when we look at the TDS, we see the different properties, and here you can see that they mostly have these kind of physical conditions, and they'll have different kinds. They have these salt spray, condensation and humidity. So, these are the quantities which will tell you that the corrosion, if you use this particular rust preventive oil, the corrosion will happen after 48 hours, the corrosion will happen after 720 hours, or corrosion and condensation test will happen after 720 hours. So, these indicate the largest after how many hours it will occur. It means that the severe conditions will even if the condition is severe, if you have a higher if you have a higher quantity, you will have the rust preventive oil will be able to prevent corrosion or will remain on the surface for that long time. So, that is why it is necessary to see what actually is going to happen. Now, usually rust preventive oils, if you look at the MSDS, consist of mineral oils, that are made from naphtha or naphtha, or during cracking of petroleum. They will also contain some kind of sulfonates, calcium sulfonate as surfactants. So, the use of these is to take that particular is to enable the oil to remain on the surface and protect that surface. So, the surfactants will prevent the corrosive solution from reaching the substrate that has been covered by the oil. It may also help the oil to wet the surface more, and it can also, the oil with the surfactants can also lead to dissolution of whatever the rust may be there before the oil is applied. So, it works in a couple of different ways. Now, TDS shows us the TDS over in the earlier case gave us these quantities. Now, when we want to do when researchers actually make or test these kind of oils, they will do electrochemical tests. So, usually they will again go to the polarization, potentiodynamic polarization, and get the curves to go on and get the quantities of I core and E core. So, I core is the corrosion current density, E core is the corrosion potential. Corrosion current density implies the rate at which corrosion will occur. So, when lower the corrosion rate, better is the corrosive, lower of this quantity, better is the corrosion resistance, and that is what will indicate which one is the best. So, now if, as you can see in the TDS, they said that 48 hours plus. So, it can mean 48 hours, 1 minute, 48 hours, 2 minutes, anything. So, that is 1 minute better than 2 minutes, or is that just a freak just for one sample, or have they done for 4 samples? It remains to be seen. So, instead of that, when researchers do these kind of tests, they can quantify these in terms of MPY, MMPY, and they can do the EIS as well for the salt spray test. So, when they do the salt spray, they can do it before and after 48 hours. So, they can see the difference in the reduction in of EIS. So, that will help to help the researchers communicate their research to industry, and industry can understand that this is fine. Okay, they have given us this oil, and its salt spray is this, and its salt spray is good, and it's matching whatever our requirements are, and that's why it's necessary to integrate those results and these results. And so, the integration will occur when we look at how they present the data. So, researchers will focus from chemistry to the images. So, here the EIS may have different quantities, and they will also do salt spray test. Industry will mostly do physical possible tests. Possibly coupons may be used to check if they are doing a third party testing. But when they are trying to integrate it, researchers, as I said, they use plots. Even if you have these kind of quantities, you can use plots to show how the difference or which one is the best. Looking at the picture will help to pinpoint the best oil quickly. What can the industry do? Industry can use third party, you do electrochemical test and relate it to the salt spray test. So, that they can actually understand what they mean when they say 48 hours plus or 68 hours plus, because salt spray tests are really severe corrosion tests. So, that is not what is going to happen when you actually are going to use a rust preventive oil. So, the best option is to try to formulate an experiment where you immerse that your component in the rust preventive oil for the amount of time that you are going to use it, and then do the electrochemical test in that real life situation. So even if so that you can actually understand for how much how those quantities given in the TDS are going to be related to your sample specifically. So, that way you can try to integrate. So, a typical integrated data sheet would look something like this. Just from this they can add more. So, it is two way. Researchers can also present their data in this way. They can take in addition to this, you will have corrosion rate from corrosion current density, you can have corrosion rate from Copen test, so that it's able to match which one would work. You will have inhibitor efficiency, and then you will have additions to the original test. So, you have salt spray, you can do impedance to see the reduction in impedance. The condensation test, same, you can do reduction, and for humidity also you can do these kind of reduction impedance tests. So, this is the kind of protection that can be done. Now, what actually happens is, this is fine when somebody is working on integrated data sheet. They can actually does take into account both research and industry. Now, that was something that I had to talk about, because I had to talk about how both the data sheets can be completed and shown together, it can be useful. So, whoever is doing the research, they can actually go on and directly present their data to the industry, saying that this is how it's going to be, so that industry can easily understand. When you are presenting in a conference, you can understand. Else, if the industry wants to do a failure analysis or explain why somebody should buy their products, they can do these kind of integrated data sheets and say that this is how it is going to be, and that's why you should use our product. This would be a complete picture of your case study. Now, that's something that was about that's something that is really useful. Now, what's next? Okay, we know corrosion, we have worked on corrosion. What's next? Usually the next comes with learning about corrosion. So, okay, you have talked about these electrochemical testing, you have talked about everything, but I don't know that. That's what people will do. We never work with this. We usually give the testing to somebody else, or so why should I do? So, what should I do about it? So, then we come to the learning of corrosion courses, and corrosion courses there are so many experts who are giving out corrosion courses. They are available on YouTube. They are available if you want to buy them from a particular organization. You have so many different experts who are giving sharing their knowledge. I have been conducting corrosion courses for almost a year now, and there are a few things that I observed. One, most of them are really expensive. So it's not possible for everyone to afford them. Next is the timings. If they are live courses, even when I conducted the courses, the timings were really not suitable for everyone. Next was, sometimes if you check out some of the videos, there may be too much focus on the theory, or too much practical, or there may be too much text or too generalization. So if I start talking about the aspects of electrical maintenance, of cathodic protection to a student of corrosion, he or she they may not be interested, because they want to learn about corrosion. Alternatively, if I start talking about the very in-depth details of electrochemistry to an industry person, they may not be interested, because they want to know how corrosion works in very simple terms. So that integration is not always possible. That's why they really want something that is simple and easy to understand. There should be examples that they have seen, they have observed, they have worked with, or so they should be able to relate to it. They should be able to discuss the corrosion issues that they want, and if I am talking about corrosion, I should be able to relate that corrosion concept to their issues, so that it's easy for them to relate it. Helps them to understand it better. And there are also people who really want a few lectures that will help them to practice the concepts. For if they are attending a certification, if they are redoing something, they would like to practice concepts, they would like to relearn the concepts from a new point of view. Keeping all this in mind, I devised this website. So a few months ago I did advertise this website. It went under maintenance as with everything new, and now I have uploaded a few courses and it's good to go. So this is the website that I designed. It is on called https corrospective.com. Here you will have here the courses are designed in a different way. So what is in this website? With all the learning that I got from the previous cases, I devised this website, and here there are 3 stages. Basically, you have a major course, you have a mini course and micro course, and all the way you select it depends on what do you actually want to learn. If you are do you want to learn corrosion of a particular industry? Do you want to learn a simple concept? How much time do you have? Are you able to dedicate a long amount of time every day, or do you want something that you can I have my weekend free, but I really want to brush up my concepts. I have only that small amount of time. Do you want to learn something new, or do you just want to refresh your knowledge, or do you want to test your knowledge? So depending on this, you can select one of the 3 courses, 3 types. At the moment, we have mini courses and micro courses from oil and gas. So mini course will include the 4 topics of electrochemistry, types of corrosion, testing and prevention. And if you do not have the time to do a mini course, each of these are further uploaded as micro courses. There is a bit different about micro courses that I will talk when I show the website. So I will talk about the website now. Now this is the website. You can see there are a whole lot of courses that I have uploaded over here. You can browse to this before you sign up. You can check out the latest courses. You can go down and see what the participants who were in my other lectures have to say about the way I taught, or have to say about the way the corrosion is framed, and then you can actually go to the categories. So there are a few different categories over here, and you can select which one works best. It's either corrosion or basics of corrosion, or you want to focus on the types or prevention methods or testing methods, what would it be? So that is a way to work. Now if you only want to browse, that's fine. You can select, you can go to one of them and on this website you have options to actually you can see what you are going to learn. You can see the description, and you can see the different topics. So here you will have the video which gives you which will show you a slight like a trailer of what the corrosion course will include. So this way you can check out what's in the course. Now what is happening actually over here? Now if you see, I will go to one category of basics of corrosion. In this you have 2 mini courses at the moment. One is in marine and one is in oil and gas. Now here in marine and oil and gas, these are of almost 3 hours each. So if you have if you don't really want to go into a lot of detail, but you still want to see the you still want to look at the you still want do a kind of refresher course, these would be the best. Now if you don't have that much time, okay, you don't have 3 hours to spend, you have say 20 minutes, you have 1 hour, you have half an hour, you can go to individual categories. So these are micro courses. In micro courses, for example, corrosion prevention, you will have corrosion prevention methods for oil and gas. Here you have corrosion prevention methods for industry. So, in these cases it is very easy now for you to go over only that topic. You don't want to go into types, you already know the types, that is fine. You want to refresh prevention methods, great, you go to this micro course and select this course. Now, whenever you want to buy, even when I want to buy a particular course, I always think whether I want to spend that amount of money or not. Even if it is as less as 99 rupees, it is still a significant thought process, especially in these COVID times. So, if you are someone who does not want to spend money, you can contact me and I will gift you this trial course. I have designed this trial course with parts of courses taken from the other courses, so that you get an idea of how the courses are designed in general and how you are going to learn it. So, if you want this trial course, you can contact me and sign up for the trial course. Now, let us see how the trial course looks like. So, when you sign up, you have this, you can go to courses and buy, and then you can select or buy whichever course you want. So, that payment is done entirely online and it's good to go. Now, when I assign you a particular course, you can actually get the trial course for free. You start the course, and at each point you will have quiz. So, you can select and you can go to that quiz and answer the questions. So, this way you can check out this trial course. It's just 11 minutes, 12 minutes, and you can if you like this, please do come back and check out the other courses. Whenever you complete this, you will get this certificate mailed directly with your name, and you will also have a mention of the professional development hours. So, that is about my website. I really look forward to connecting with you. Some of you have already signed up. Please check out the trial course, and you can then come back and join the other courses as well. So, what are the upcoming courses? Upcoming courses include cathodic protection courses focused on basic concepts, and there will be micro mini courses both. There will be coating courses, some of them specifically related to metallic coatings or organic coatings for industry. Then there will be corrosion inhibitors. This would include different courses for scavengers. Everything is focused on focused on the information that is required by industry personnel, and also for students and researchers to see how industry thinks and how to take the basics and relate it to the industry. So, that is all about my webinar. Unfortunately, the live did not work that well. That's fine. I'm uploading this video, and I hope to see all of you on the website. Please do come back to me if you want a trial course, and I'll assign it to you. Thank you so much.